So basically we talked that on how to calculate the temperature, but let's not talk about it and let's jump into it, okay, because I was running out of time. Now you're basically first calculating the scale, which every engineers do, which is Celsius, okay, and what you need to do is put your thermometer into a bucket of ice. Or I should say bucket full of ice. But okay, you get the point. Okay. Now how does it look like? Well, you have a bucket over here and all the ice is there. Okay, this is basically ice. And you put that thermometer over here. Okay? Now when you put thermometer here, the water, okay, the water is actually at so-called the ice point. Now let us know what actually ice point is. So let me go ahead and explain to you guys what actually ice point is. So basically what ice point means is that, well, all the ice point means that right at the freezing point, where it means that it's just about to freeze, but it hasn't quite frozen yet. So that's ice point. And likewise, you can say that if you put ice into water, what happens is you're basically adding heat to it. Okay, now it's just about to melt. The ice is just about to melt, but it hasn't quite melted yet. So basically that's called the ice point. And we have ice all over the place over here. Here. Okay, let me just illustrate it. So basically you have ice over here, everywhere. The bucket is full of ice. Okay, you can think of it as that. Now you get some temperature reading. Okay, now let me just draw one accurate temperature scale, which is over here, so I'm not gonna mess up. Okay, now this is our temperature scale, which we label. Now exactly at the ice point, when you take the thermometer out, you have a scale over here, okay, which basically reads, you need to label that as 0 degrees Celsius. Because it's 0 degrees Celsius, it's the freezing point of water. Okay, the freezing point of water is called 0 degrees Celsius at the ice point. Now let's go ahead and label some more parts to it. Okay, which is in Celsius. Now all you need to do is put the bucket of water. So basically, now from ice, you're putting it into water. So basically, this is all water, okay? Let me just go ahead and erase it. Oh, great. So basically you have a bucket, water. What you need to do is put the bucket over here, or a bowl you can say, into your gas, okay? So basically your gas would look like this. If you live in the United States, it would look like a coil, lots of coils. Now you have your thermometer over here, and you already have your labeled thermometer labeled over here as well. Now what you need to do is turn on the gas. Okay, turn it on. Okay, and right about at the boiling point. Now what I mean by boiling point is that you guys already guessed that right at the point when the water is just about to turn into steam. So when you see the steam, little bit of steam coming out, turn off the gas, take the thermometer out, okay? And the mercury is going to show you some reading, and you need to label that reading. Okay, I'm just gonna zoom in, and you need to label that reading. We'll show you some right here, and you need to label this as 100 degrees Celsius. And what you did is basically discover two parts of thermometer. Now you need to divide this into 10 equal parts, so you have 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, and so on. Okay, now let's go ahead and talk a little bit more about having more temperature scale, okay? But before moving on to that, let's just go ahead and, for the heck of it, let me just draw a bar graph, okay? Graph that shows this, what we already talked about. Now, if we go ahead and draw a graph, it would basically look like this. Now, we say that this thermometer over here basically uses some kind of energy. And we also say that it's not those kind of energy that we use to lift objects. So none of the forces are acting on it. What force is it? What the type of energy is it? The kinetic energy, right? So basically we use kinetic energy and the temperature. Now we already discovered the 100 degrees Celsius and 0 degrees Celsius, right? So basically you're right here and you add heat to it, okay? So basically what it would look like is here, over here. Okay, so we talked about 0 degrees Celsius to 100 degrees Celsius, that even spacing, okay, 10 equal spacing marking over here. Now Kelvin, okay, let me just try. Kelvin is what we use in advanced physics, okay, is same degree we talked about in Celsius, so it's the same degree we actually talked about, but there's exceptions, okay, talked about as Celsius, and the exception is that but absolute 0 is the reference. Now let me just go ahead and highlight this, what the difference is. So from here to here, that's the difference. Basically, we said that it uses the same kind of thing that we already talked about in Celsius. Now the additional point, what it's adding to Kelvin, is that it uses absolute 0 as reference. Now let's go ahead and go back to the graph over here. Now absolute 0 is when you have absolute 0 value, zero kinetic energy, and that point locates over here. Absolute 0, as you guys can see. Okay, now, well, how low can you go? Sooner or later, this molecules of water, because we have water over here, we took water as a substance over here, so sooner or later this water is going to freeze and the atoms will basically stop moving. Okay, the atoms will basically stop moving. Absolutely, they will. When you know if the temperature is high, it moves faster. If the temperature is low, it moves slower. But when you have absolute 0 reference, basically stops moving. Okay, so let me just go ahead and erase the board. After in our next section here, I'm going to pause the video. So if you want to learn more, click on the link in the description. Thank you.